Looking at the beautiful pictures and videos of galaxies and different astronomical objects in the universe, you might think that the universe is a bright, light and shiny kind of a place. But that's not really the case. There is a huge, hidden, mysterious, dark side to this universe. Actually, everything we see in this universe, you, me, planets, stars, the galaxies, everything we see and know only makes up about 5% of this entire universe. Almost 25% of the entire universe is made up of something called the dark matter. And almost 70% of the entire universe is made up of something called the dark energy. And although these terms may sound straight out of a sci-fi novel, they are actually the cornerstones of modern cosmology. But what is dark matter and dark energy? And if we can't see it, taste it, or smell it, how do we know it exists? Today we will take a look into what is dark matter and what is dark energy and why they are so important in the universe. Let's start with gravity. Gravitational force holds our entire solar system together. It makes the Earth go round and round around the Sun, and it makes the Moon circle around Earth. Our Moon moves around Earth at a speed of almost 1 kilometer per second. But what happens if somehow the Moon starts to move faster and faster? At some point, Earth's gravity won't be strong enough to keep holding onto the Moon, and the Moon will fly away. The situation is similar to tying a stone to a thin string and then rotating it. As you move this string faster and faster, at some point the string breaks and the stone flies away. Now, the important thing to note here is, if in our stone and the string example, the string was thicker, it would be harder for the stone to fly away. Similarly, if Earth was bigger, it would have been harder for Moon to go away, because the bigger the body, more gravitational force it can apply. Just like the Moon revolves around the Earth and Earth revolves around the Sun, on a cosmological scale, the galaxies also revolve. In year 1933, astrophysicist Fritz Zwicky was trying to measure how fast these galaxies move around. And what he observed was mind-blowing. He realized that the speed with which these galaxies were moving was way too fast. In fact, it was so fast that at these speeds, all the stars in the galaxy should start to fly away. All these galaxies should start to disintegrate. The observed mass of the galaxy is not enough to produce a gravitational force that can hold together all the stars into the galaxy when these are moving at such high speeds. His conclusion was that there must be something else present, something hidden, something mysterious, something dark that is unseen and unknown, which is producing this huge amount of gravitational force holding together the structure of the galaxy. Not only that, the entire structure of the universe can only be explained by the presence of dark matter. Dark matter produces a massive amount of gravitational force, a force that cannot be accounted for by the visible matter, by the visible stars, planets, galaxies and everything else in this universe. But the problem is, dark matter is pretty much of an introvert. In fact, it is the biggest introvert in the universe. It doesn't interact with anything. Only way it shows its presence is by producing huge amounts of gravitational force. Now, one of the interesting aspects of gravitational field is that when light passes near a massive object, the gravitational field produced by this massive object bends the light. This phenomena is called gravitational wave lensing. So technically, when light passes near a massive galaxy, it will bend the light, and by observing the curvature of the light, the bending of the light, how much it bends, we can tell how big the galaxy is, what is the mass of the galaxy. And observations have again and again shown that when we observe this bending of the light near galaxies, the light bends way too much than that can be accounted by the visible matter in the galaxy, clearly implying that there is something else inside this galaxy that we cannot see, but it is producing such huge amounts of gravitational force that it's bending the light way too much. Now let's turn the page to what is dark energy. Let's start with blowing some air into a balloon. When you blow air into a balloon, it starts to expand. And the more air you blow, the bigger it becomes. When you stop, it stops expanding. But what if it doesn't? What if instead of stopping, it starts to expand faster and faster? That is exactly what's going on with the universe. And the answer to this question lies in dark energy. In year 1930, Edward Hubble, while observing distant galaxies, realized that the galaxies are moving away from us. We use something called Doppler's effect. Astronomical objects, when they are moving away from us, the light coming from them is shifted towards the red side of the spectrum, and it's called the red shift. And if they are coming close to us, the wavelength of light from them is moved towards blue side of the spectrum, and it's called the blue shift. Using the concept of red shift, he realized that the galaxies were moving away from us. And not only the galaxies, the entire universe is expanding, is moving away from us. Now, even though we realized that the universe was expanding, we expected the universe to stop expanding after some time. Because the universe contains all these planets, stars and galaxies, and they all apply the gravitational pull, this gravitational pull should act as a drag on the expansion of the universe. So over time, the rate of expansion should start to slow down. But as is the theme with almost all the scientific discoveries, that was not the case. In 1990s, while observing supernova explosions, it was realized that the expansion of the universe, instead of slowing down, has increased. The universe is expanding at a much faster rate. The expansion of the universe is accelerating. Now, going back to the balloon analogy, if your balloon starts to expand faster and faster, you would think that there is some sort of mysterious and hidden energy inside the balloon which is pushing it outwards. This hidden or mysterious energy is what we call the dark energy. And that is exactly the case with the universe. We expect that there is some sort of hidden, mysterious, dark energy in the universe which has a negative value which is pushing it outwards. And this energy is so huge that it's overcoming the entire gravitational force of all the baryonic matter in the universe, all the visible matter in the universe. But in the case of the universe, since the size of the universe is unimaginably huge, the size of this dark energy would also have to be unimaginably huge in comparison with the visible matter, in comparison with the gravitational pull applied by all the matter in the universe. Now, understanding this dark energy is extremely difficult because the only way we observe it is in the expansion of the universe. And while many solutions and theories have been presented to explain what is dark energy, the simplest solution comes from what we call the lambda CDM model. According to this model, the thing we called vacuum, nothingness or empty, is not actually nothing. It's in fact filled with something called dark energy. And more vacuum there is, more dark energy there will be. So take for example the case of two galaxies which are placed far away from each other, as is usually the case with everything in the universe. When these galaxies are placed far away from each other, there would be a huge amount of vacuum in between them. Now this huge amount of vacuum will be filled with this huge amount of dark energy, and this dark energy will start to push them apart. Further apart they become, more vacuum there will be, and more vacuum there is, more dark energy there will be, and even more push will be applied on them. Now this case will be happening across everything in the universe, and so everything will be pushed apart faster and faster, and hence explaining why the expansion rate of the universe is accelerating. Now we know that there is something mysterious going on with the universe, something that cannot be explained by the visible matter in the universe. But our understanding of this something is extremely feeble and lacking. Dark matter and dark energy are added to the long list of things we don't understand yet, and the knowledge of which could change entirely our current understanding of the universe. So again, what is dark matter and what is dark energy? It's a mystery.